Good day, math learners! In this video, we will talk about the concept on the deciles of the group data. What are deciles? Deciles may be defined as a point in scale where the distribution is divided into 10 equal parts, counting above from below to include the lowest class limit. We locate the first decile, d sub 1. Incidentally, the fifth decile, or d sub 5, separated from the fourth and the sixth deciles of a distribution, is equal to the median and the second quartile q sub 2. Note that the deciles d sub 1, d sub 2 up to d sub 9 are division points on the measuring scale between the 10 equal parts. How do we solve the deciles of the group data? The formula for deciles of the group data is given below, wherein R is equal to 1 for the first decile, 2 for the second decile, 3 for the third decile, up to 9 for the ninth decile. LBDC is equal to the lower boundary of the decile class, sigma f, summation of the frequencies, CFB, cumulative frequency of the lower class below the decile class. FDC is equal to the frequency of the decile class and I for our class interval. Let us consider the first example. The following are the heights in centimeters of 35 students, given this data. So our goal for this first example, first is to construct a frequency distribution table, second, to find d sub 3 or the third decile. This is now our frequency distribution table on the heights of 35 students. We've been using the same data on our previous lesson on the frequency distribution table. So on the first column, we have the heights in centimeters, the class boundaries, the tally, the frequency with the summation f, which is equal to 35, and the less than cumulative frequency column. To find the value of the third decile, first we have to find the following values, and then substitute them in the formula for d sub 3. To solve for d sub 3, first we have to find the value of the decile class of d sub 3 or the third decile, using the formula R times summation of f divided by 10. So this time, our R is equal to 3 since we are looking for the third decile, and our summation of f is equal to 35. Substitute them to the given formula, and then simplify. Therefore, our d sub 3 class is equal to 10.5. We will locate this value from the less than cumulative frequency column and highlight the entire row on where it belongs. Since we already have the value of our d sub 3 class, which is equal to 10.5, we will locate this one from our less than cumulative frequency column. So, where to locate 10.5? So, let us take note of the following. So, this column talks about the students, meaning to say, so from this first row, we have students 1 to 2. Then in the next row, we have students 3 to 6. Then on the third row, we have students 7 to 15. On the fourth row, we have students 16 to 27. Then on the fifth row, we have students 28 to 34. And lastly, student 35. So in this case, 10.5 belongs or is under 15. So we have to highlight the third row and label this one as our d sub 3 class. And we have to find the following values. So we have 129.5. This will be our lower boundary of the decile class. 6 will be our cumulative frequency below. And then we have 9, which is our frequency of the decile class. So we have here the following values needed to solve the decile of the group data. So this is now the formula in finding the decile of the group data. Substitute the given values, and then so we have to simplify. Then d sub 3 is equal to 132. So we have to make sure that your final answer should be rounded off to 2 decimal places. At the same time, it should be within the decile class of 130 to 134. So after solving for the value of d sub 3, which is equal to 132, so let us now interpret this result. This means that 30% of the students have heights less than or equal to 132 centimeters. Let us proceed to our next example. Find the sixth decile of the data below. So our data is all about the scores of Creighton students in their math test. So we already have this table here. So the first column talks about the scores. Then we have the class boundaries. Then we have the frequency, and lastly, the less than cumulative frequency. So the summation of F in this data is equal to 50. Find the values of the following and then substitute them in the formula in finding d sub 6. To solve for d sub 6, first we have to find the decile class of d sub 6 using this formula. Our R here becomes 6 since we are looking for the sixth decile. And our summation of F is equal to 50. Substitute the given values and then simplify. Our D6 class is equal to 30, after which locate this value from the less than cumulative frequency column and highlight the entire row on where it belongs. Our D6 class is equal to 30. So going back to our frequency distribution table, so we will be locating 30 from the less than cumulative frequency column. So this less than cumulative frequency column here, so this would be the students. So we have students 1 to 3 on the first row, then students 4 to 6, followed by students 7 to 16, students 17 to 24, students 25 to 37, students 38 to 46, students 47 to 49, and lastly, student 50. So we have to locate 30. 30 is under 37. So we will be highlighting this entire row. After which, we have to label D sub 6 class. And then, we have to find the following values. So we have 59.5, which should be our LBDC. 24 will be our CF below. 13 would be our frequency. Then to find the interval, so since we already have this table, to find the interval, we will just use this class limits of 60 to 69. So you start counting from 60, then up to 69. So this will be the first or another way in finding the class interval. So upon counting from 60 to 69, you count how many numbers are within this given class limits. So upon counting, we have a total of 10 quantities. Therefore, our class interval is 10. Another way also in finding the class interval, we can make use of your lower limit. Like for example, 70 minus 60. So still it gives us an interval of 10. So that is also another way in finding our class interval. So we have these values here. So these values are needed to solve the value of d sub 6. So we will be using this formula to find the decile of the group data. Then substitute the given values. And then we have to simplify. So our d sub 6 is equal to 64.12. So round off the final answer to 2 decimal places and make sure it should be within our decile class of 60 to 69. Then after which we have to interpret. This means that 60% of the students scored lower than or equal to 64.12. Let us consider this example. The following table show the weights in kilograms of 50 high school students. Find d sub 8 and interpret the result. So we have here the weights in kilograms on the first column and given this frequency. So in this case, as you have noticed, we don't have the columns for the class boundaries and the less than cumulative frequency. So we have to complete the table by adding the class boundaries and the less than cumulative frequency columns. For class boundaries, we will be using our class limits 40 to 42, then so on and so forth. So that we can find our class boundaries, we will be using our lower limit 40 and subtract it with 0.5 so that it becomes our lower boundary 39.5. Then, in this case, we will be using our upper limit 42, then plus 0.5 so that we can have our upper boundary which is 42.5. And then do the same with the next rows. Then for this column, you add everything so that we can have our summation of f which is equal to 50. For the less than cumulative frequency column, we will copy the frequency from the lowest class, which is equal to 1, after which we have 1 plus 1, it becomes 2, 2 plus 2, 4, 4 plus 3, 7, 7 plus 6, 13, 13 plus 7, 20, 20 plus 15, 35, 35 plus 8, 43, 43 plus 7, 50. You have to make sure that the less than cumulative frequency of your highest class should be equal to your summation of f. After completing the table with the needed columns, find the values of the following and then substitute them in finding d sub 8. To solve for d sub 8, find the value of the decile class of d sub 8 by using this formula. So our r here is equal to 8 since we are looking for the 8th decile. And our summation of f is equal to 50. Substitute them to our given formula and then simplify. Thus, our d sub 8 class is equal to 40. So our D8 class is equal to 40. We will locate this value from our less than cumulative frequency column. So since our data is all about the weights of the students, therefore, in this column, these are all students. So we have student 1, we have student 2, followed by students 3 to 4, students 5 to 7, students 8 to 13, students 14 to 20, students 21 to 35, students 36 to 43, and students 44 to 50. So where do we locate 40? So 40 is under 43. So we will highlight this entire row and label as D8 class. Then label the following. 60.5 will be our lower boundary. 35 will be our CF below. And 8 will be our frequency. To find the interval, we will just count starting from 61 to 63. Then you count how many quantities are within this class limits. So the interval here is equal to 3, or you may use this way or this method. You can have 64 minus 61. So it gives us a difference of 3. So that is also our class interval. These are now the values needed to solve our D sub 8. So use this formula to find the decile of the group data. Then substitute the given values. Then simplify. Therefore, our D sub 8 is equal to 62.38. Round off your final answer to 2 decimal places. Then make sure this answer should be within the decile class of 61 to 63. And then interpret the result. This means that 80% of the students have weights less than or equal to 62.38 kilograms. And this ends our lesson on the deciles of the group data. Thank you.